Alright, in order to simplify this expression, the first thing I'm going to do is to prime factor this number inside the fourth root here. Actually, we need a little fourth root symbol. The prime factorization of 256 is 2 to the 8th. So rewrite this as 4, and then 2 to the 8th, and then x to the 11th. Alright, and so the process of actually taking the fourth root of this stuff, and again, we're not caring about this negative 3 on the outside. All that I'm really caring about is what's happening underneath this radical right here. I want to take the radical as much as I can underneath this. But when I take the fourth root of something, I end up dividing the exponent by 4. And specifically, what's not going to work nicely with that is this x to the 11th right here. So what we're going to do is we're going to rewrite x to the 11th, and we're going to write it as two factors that equal to the x to the 11th, but one that has the highest multiple of 4, something that can be divided by 4. That's what all multiple is. So I'm going to rewrite x to the 11th as x to the 8th times x to the 3rd. Okay, so rewriting this expression, we'll get negative 3 fourth root 2 to the 8th times x to the 8th times x to the 3rd. Okay, the next move is pretty straightforward, but really is what confuses some people. What I'm going to do now is I'm going to take the fourth root of everything under this radical that I can in a nice way. What that's going to entail is taking the fourth root of this 2 to the 8th and the x to the 8th. I'm not going to take the fourth root of x cubed because it won't work nicely. Specifically, I can't divide this exponent by 4. So what I'm going to do is I'm going to apply the fourth root to these two factors and leave the x to the cube underneath the root. And so what that will look like is this. So I have this negative 3. It's really just hanging out here doing nothing. It's a lazy number out there. 2 to the 8th. When I take the fourth root of 2 to the 8th, I divide the exponent by 2, so that becomes 2 squared, or 4 is really what that comes. And x to the 8th, when I take the fourth root of that, becomes an x squared. So these are the factors that I've actually taken the fourth root of. And that's why there's no fourth root symbol of them anymore. These represent these two factors, but I've taken the fourth root. What gets left under the radical is just the piece that I couldn't take the fourth root of. And I couldn't take the fourth root of this x to the cubed because the 3 can't be divided nicely by the 4. And there's no multiple of 4 that's less than 3, and so it's completely simplified. So my final answer, I'll just clean things up. You know, this 2 squared is a 4, so 4 times negative 3 gives me a negative 12. That's literally the only part of this problem where that negative 3 came into play. And I have this x squared that's on the outside, and then this fourth root of x cubed. So again, in my original problem I had this 256 and x to the 11th. What I did was, well, first I rewrote 256 as 2 to the 8th. The reasoning for that, I could try to figure out what the fourth root of 256 is, but instead I'm going to treat these all the same, each factor the same, and I can do that if I use this prime factorization. So if I write 256 as 2 to the 8th, then the only thing I'm thinking about is I want exponents that are multiples of 4, so that when I take the radical, it will work nicely. I can divide those exponents by 4. This x to the 11th, again, what I had to do was I had to break that up, because 11 can't be divided by 4. 8 here is the highest multiple less than 11. So I could have used x to the 4th, but x to the 8th is bigger. And then this x to the 3rd is just this leftover piece, because I had 11 x's. And those leftovers are what ends up occurring or showing up in the radical in the end. And along the way, the x to the 8th and the 2 to the 8th, I ended up dividing those exponents by 4, because I actually could take the root of those two factors.